Hello and welcome back to another Physical Sciences 3 lecture. So this time we are looking at work, and as it says here, work is done when a force F causes an object to undergo displacement S. So when a force makes an object move. And we can calculate the amount of work done by this equation here. So work done is equal to force times displacement. Work is a scalar quantity. Okay, so that means that we do not need to worry about direction, even though both force and displacement have directions. We don't have to worry about it in terms of work. The units for work are Newton meters, which you can kind of work out if you think about force has units of newtons, and then displacement has units of meters, newtons and meters. So that the units for work are Newton meters, but they're also given the name joule. So you might have heard of joules before because it's also the unit for energy. And we'll talk about the relationship between energy and work later on in the course, very shortly in the next lecture in fact. So note that if there is no displacement, if there's no displacement, then no useful work or mechanical work is being done. You can push against a wall all day, but if the wall does not move, you have not done any mechanical work, even though you might have used a bunch of energy. So we'll talk about that later on as well. So let's have a look at a couple of examples. So how much work is done by a force of 35 newtons east that moves an object 12 meters east? So work is equal to force, 35 times by 12. And we put that into our calculator, which I've done before. We got 420 Newton meters. 420 Newton meters, or you could say joules. Alright, and just remember it's a scalar, so even though they're both acting in the eastward direction, we just have to say, well, 420 Newton meters or 420 joules of work is being done to move that object. So in this one here, we have a motor which lifts 100 kilograms, 100 kilogram load through 15 meters at a steady speed. So work, again, is equal to force times displacement. But let's think about what's happening here. So we have this 100 kilogram load, and it's being moved up 15 meters, and we know that gravity is acting on it. So even though steady speed means that acceleration is equal to 0, which implies that the net force, if we remember what we did last time, is equal to 0, because net is equal to mass times acceleration. But it also means that this force is equal to the gravitational force, so that overall the net force is 0. It means that those two are balanced. It's equal to minus the gravitational force. So when we're considering the force, we have to consider sometimes what is the force that we're overcoming in order to do the work. And in this case, the motor is overcoming the force of gravity to lift this 100 kilogram load. So the force of gravity would be 100 times 9.81. So that's our force. And it's going to be times by 15 meters, the distance that it's, or the displacement that it's lifted it through. And then when we work that one out, we end up getting, I did that calculator earlier as well, just to practice, so 14,715 Newton meters. Or joules. So we call it joules this time. And I'm going to approximate that to 15 kilojoules. So just remember that K stands for 1,000, so 15 kilojoules we can approximate that, and that is two significant figures. Alright, so next time we're going to look at energy and how that relates to work.